Hello, my name is Nicolás Cortes. I'm a student of aeronautical engineering from the University Libertadores. In this video, I'll explain the exercise 6.133 of the book Beer and Johnson, 9th edition. For this exercise, we have to find B so that the crank AB is equilibrium when the angle is equal to 0 degrees and the same angle is equal to 30 degrees. When the angle is equal 0, we have to make the diagram of the point C, B, D, and thus make the moment at point C, this point, in order to find point B. The distance of the points are passed from millimeters to meters. This is the diagram of the axis CBD, and this is the distance we have to pass from millimeters to meters. To pass millimeters to meters, the millimeters we want to pass to meter are divided by 1000. For example, this distance we have to pass 2 meters. That is divided 1000 meters. That this is equal to 0.5 meters, and we have to change this distance. It's the same pass. That is 0.7 meters. When we have this distance, we can make the moment in C in order to clear point B, like this. Moment in C is equal 0. That is, this force B, that this force we don't know per this distance, this distance, because this distance is the distance of B, less this point, that is this force, that is 1200 newtons, and this is per this distance, that is in meters. For find B, we have to pass this, here is equal 0. For find B, we have to pass this force and this distance, that is the distance and force in D, and this is divided with the distance in B. Divided with 0.5 meters, and the point B is 1680 newtons. We have this point. After finding point B, we make the crank diagram for find M, this diagram. Then we make the moment at point A. We have this point to find M, and thus clear M as we did previously, like this. And so we can find M when the angle equals 0. Here we have to change this distance to like this, 100 millimeters divided with 1000 meters is equal to 0.1 meters. And then we have to do the moment in the point A, that is equal 0, 0, that is M less this force, that is this force, what is 1680 newtons per this distance, that is the distance of the point B, is 0. We have to do the same of here. M is equal, we have to change this distance, 1600 newtons per 0.1 meters, and the point M is this, newtons per meters. The next part of this exercise said that we have to find the point M, but with this angle is equal to 30 degrees. For this point, we have to find the distance of BC, this BC, and the beta angle, that is this angle that we don't know what is. For this, we have to first find the distance between A and B, that is this distance, because this distance we know. For this, we have to make a triangle here with the angle 30. Here is 30 degree, and here is 50. And to find this, we have to multiply this distance, that is 100 millimeters. 100 millimeters, here is millimeters too. This is multiplied by cosine of 30 degrees. And this, with this, we can find this distance. And now we have plus this distance with this distance to find the distance C to here. 86.6 plus 100 millimeters, that is 186.6 millimeters. Then of this, we have to find the angle beta. And here we have to chart this. Tan of beta is this distance divided with this distance. And we can find the angle, the beta angle, that is 5.87 degrees. Beta is equal 5.87 degrees. Now we have to find this distance from here to the point B, that is BC. The distance BC is equal to this 50 plus this. Now we found the distance BC, that is 489.1 millimeters. Now we have to change this distance from millimeters to meters. For this we have to divide this distance by 1000 millimeters divided with 1000 meters, and this is 0.48916 meters. Since we find the distance BC and the angle and the beta angle, we make the moment in the point C to be able to find this force and the point B. Here we have to do the moment in C, that is equal 0. That is this force, this point B, this multiplied with this distance with distance less the force in the point D, that is 1200 Newton. 1200 Newton, and this is multiplied by this distance, that is 0.7 meters, multiplied by cosine 587 degree. We are multiplicating with this because we are taking the axis y. Now we have to find the point B. So B is we have to pass this. Here is equal 0. We have to pass this this force and distance of the point D, that is 1200 newtons per 0.7 meters, cos. Now we have to divide per this distance, that is the distance of B. And now here we found B, that is 1708.2 newtons. This is the point B. Now we find the point B, we can find the moment, this point. We carry out the racks in the point A to find this moment in M here. Now for this we have to add the angle of 5.87 degrees plus the angle 60 degree. This is the angle A, okay, A. And here we have this angle that we will use to find the point M, okay. Now we have this angle, okay. Now I'll do the racks in the point A. That is equals 0, and here this is this force, that is M, less this point, that is this newtons, and we have to multiply this point with this distance with sin of this angle, because we are taking the axis X, okay. Sin this angle. And now we have to find this, that here we have to pass this, and we have used to operate, and here we find the point M with the angle 30 degree. Here is this 2 newtons per M sin 87 degrees, and the point M is 155.90 newtons per meters. And this is all of this exercise. Thank you for watching this video.